Hi there. I'm going to talk a little bit about your first experimental procedure here for the semester in the remote mode here. It's kinetics, chemical kinetics, which connects in very well with the first chapter that we've covered. We're going to start the experiment a little bit late because I wanted to give you some time to cover the material in the lecture portion, chapter 14. But I'm going to talk a little bit about the experiment here today. And so let me bring up the announcement. Okay, so here's the announcement talking about the report. The links to the videos that you want are right here. These are the kinetics video links there. Okay, so the idea would be that you open up the procedure in the course documents. So that's in course documents of Blackboard. You watch those two videos. Follow along as the instructor goes through the experimental procedure. Follow along with the procedure, of a hard copy of the procedure that you have there. Okay. Then you work on your report. Okay. And then you're going to submit your report. Okay. So it is time sensitive. Be aware that there's a time that you have to have this done. Okay. So what I'm going to do is I'm going to bring it over here to the course content. There you go. Now you can see this a little bit better. So I put this up at the top, Kinetics Experiment Procedures. So you're going to look at that first. Then you're going to look at the kinetics report instructions and data sheet. And of course, this is all background information down here. So those are the two forms that you want to have available. I would print them out, okay? Otherwise, you're going to be switching back and forth between documents. It's pretty hard to do that sort of thing in meanwhile while you're watching a video, if you know what I mean. Okay, so get these printed out. I'm going to show you what they look like. Okay, so this is the printout of the procedure. This is called the procedure. So it's kinetics, the oxidation of iodide by hydrogen peroxide. It gives you the goals. There's a discussion of the theory, which is connected into your textbook material. There's actually a couple of pictures in here of what it will look like when the reaction takes place, but you'll see that in the video. Some discussion of the kinetics in there about the rate and such. All these sorts of things are in here. Okay. Then the procedure is here. So this is telling us how we perform the experiment. It's got all the solutions in glassware and then instructions step by step. Now notice that when you get to page 4, there's two charts. There's chart 1 and chart 2. This experiment, we're just using chart 1. You can ignore chart 2. It's not going to be involved in it at all. There's 5 experiments that are done here. These are the numbers that are used here. Okay. Again, step by step. When you get to this part, experiment 3, again, it's just this data up here, not the one below. Okay. This is telling you how to go about it, how to do the reaction. And then you get to some data sheets. So these are data sheets here. This is where we put numbers in. And we're going to use actually a different data sheet, the one that I posted on Blackboard. Again, more data sheet, data. Then you get into the calculation. So if you notice, there's table 1, table 2, table 3, table 4, table 5, table 6 is right here. It's hard. Oh, sorry, table 5. It's actually table 6. There's 6 tables. Sorry. I'm sorry, that was 5. So here's 6. And then 7. A lot of tables here, a lot of data, a lot of calculations. Okay. So be careful. What I recommend doing is you just do one at a time. Start off with baby steps. start off with the first one. This is actually the most difficult and complicated set of calculations we do in this laboratory, okay? But it all starts here with some concentrations and some times and some more times with the effect of temperature, another time with the effect of, that's data. Then it's all calculations here, okay? So I'm gonna run you through some of the calculations here, but that's all the data right there, okay? Now, one of the things that will make this a little bit more complicated is that we're gonna have you use another set of data, not the one that the instructor is doing in the video, okay? So we have a new set of data. So this is off of Blackboard. This is the report sheet. These are the instructions for writing your report, okay? It's talking about all the tables in here and the graphs. You have tables and graphs, and then answering these 4 questions. So it's a very lengthy process. That's why you have a couple weeks to do it, is because it's pretty lengthy. Here is that first data set. The concentration of Ki is right here. The concentration of Na2S2O3 is right here. And the concentration of H2O2 is right here. Temperature is given. These are the average time, the data in terms of numbers are right here for experiments. These are the times and the temperatures for part 2. And then this is the temperature and time for part 3. So actually, this is the data set that you're going to use to do your calculations, right? So it's actually not that much there, right? If you think about it, you just have some concentrations, 5 times here, another 5 times here, and then a temperature with the time. Of course, there's temperatures with those as well. It's not really that much data, but from that data, we can go through a lot of calculations and actually determine a lot of stuff about kinetics. So it's actually very cool, all right? So what I'm going to do is I'm going to bring us up back to, let me close that one off. Table 1. Here's table 1. So this will be your first set of calculations that you do. Now, keep in mind, when you turn in your report, you're not going to just fill this in by hand, take pictures of it and submit it. You're going to actually make your own table in some sort of either a Word program or I would use like a documents program. And you're going to make your own table, okay? And you're going to have the headers in here like that and such, okay? Everything's going to be typed up in terms of this report. So let's take a look here. So this right here in the report, actually in the procedure, tells you how to do the first calculation here. What it says is we're just trying to find the initial moles. So how many moles of each reactant? And there are 3 reactants that we're concerned with. The first one is potassium iodide here, Ki. What we do is we take the molarity, the concentration of the molarity, means the same thing, of Ki, and we multiply it by the volume. Remember, molarity is moles over volume. So moles would be molarity times volume. So here's molarity times volume. Notice the units are in liters, not milliliters, but liters. They have to be converted into liters. You'll have to do that on your own. That will give you the number of moles of Ki that were added to the solution. So what we do here is we write down that molarity. There it is, 1.0. We write down the volume in liters, 0.01. That's right there. Multiply those together, and then we have our initial moles here, 0.01 moles. Does that make sense? Molarity equals moles over volume, so moles equals molarity times volume, or volume times molarity, okay? And then you're going to do that for all 5 experiments. This is part 1. Then you're going to do the same thing for the sodium thiosulfate. Then you're going to do the same thing for the hydrogen peroxide, okay? So let me go back and I'm going to show you that chart, okay? So you look for K, there's the point there's the 10 milliliters, okay? And the concentration was 1.0 moles per liter. Okay, so concentration or molarity times volume gives you moles. Okay, so you're used to using those numbers. So you're using, here we go, the volume of Ki and the molarity of Ki. Now the molarity of Ki, in each time that we're adding these, each experiment, it's the same. It's 1.0 molar. Okay, so let me come over here. Oops. There we go. Okay. So I'm going to make a table here using, this is Google Docs, drive.google.com. You know, it has, for some reason, it has different names. So I'm going to do the potassium iodide first. So I'm going to do Ki. And I've labeled this down as table 1. So anytime you want to add, do more calculations on a different sheet, you just hit this little plus and that adds a sheet and you can do that. Okay. So, you know, the first one is where we have 10 milliliters. So that's 0.010. And I'm not going to write the number of milliliters. I'm going to write the number of liters with that. Okay, even though when you do the experiment, you add it in milliliters. The second experiment is 0.02 liters. And then the third experiment is 0.03. And then it stays at 0.03 for the last two experiments. Okay, so let me come up here. There should be a way to make this look a little prettier. There we go. I'm just gonna, okay. And then let's actually go ahead and title this volume Ki, and then I'll put in parentheses L for liters. Okay, so 10 milliliters, 20, 30, 30, 30. Okay, again, I'm getting that from that chart 1 of the procedure. And then in the next table, I'm going to have the molarity of Ki. And then I'm going to go ahead and put the units here. This is helping me just kind of figure out how I'm going about doing what I'm actually doing in the calculations. And then moles Ki. And moles are actually the units. There we go. Okay. And of course, if you want, you can, you know, you can underline them too if you want. I'm not going to though. Okay. Now the molarity is given as 1.0. That's in your data sheet. I'm using the same molarity in the data sheet that I put on Blackboard as is in the actual procedure. That's no different. It's 1 molar. Okay. Next thing I'm going to do is I'm just going to do the calculation. And now this is very easy. All you do is you hit equal sign. Anytime you're going to do some sort of calculation on one of these spreadsheets, you hit equal. So you can do it either order. Remember, multiplication commutes. So you can do molarity times volume or volume times molarity. So I'll do molarity times volume. So this one, cell B2, times. Now times, you use the little asterisk above the 8 key. And then you click the other cell, which is A2, and then you just hit return. And that's going to do the arithmetic for you. Now, the nice thing about these spreadsheet programs now is they then kind of try to figure out what you're doing, and they'll actually make some suggestions. This says autofill. So if you click that autofill, it'll just do every calculation in the same way that you did it. It'll take, in the third row, it'll take A3 times B3, right? The volume times the molarity, and do it just like you did. So if you hit that, boom, you got them all, okay? That's kind of cool. So there's your first part. Now, in the table, And when I say the table, what I mean is table 1. Okay, so table 1 is what we're doing. So let me come back and bring us up to table 1 just so you can see this. There we go. The next one is sodium thiosulfate. Okay. Na2S2O3. Why is it? It's called sodium. So remember, you're in chemistry, right? So Na2, Na is sodium. S2O3 is the thiosulfate anion. So it's sodium thiosulfate dissolved in water. It's one of the reactants. So its molarity is given here. The volume that's being added for each experiment is given here. And then you're going to just do the same thing. You're going to calculate the number of moles there. Okay? Does that make sense? So let's come back over to our spreadsheet. Okay. So you know what I'm going to do? I'm going to be a little clever. I'm going to copy those 3 cells. So copy, paste, oops. And then I'm just going to change Ki to Na2S2O3. Now that actually doesn't look real good. So I'm just going to widen that a little bit. Okay. Same thing here. Na2S2O3. Doesn't look real pretty, does it? So I'm going to widen that one there. And then same thing here. 2O3. It's not as hard as creating a group chat on WhatsApp. It's actually easier than that. Okay, so now we want to have our numbers here for the sodium thiosulfate. You go back to chart 1, and for sodium thiosulfate, it's the same every time. It's 25 milliliters. Okay. Then you get to the molarity. Now the molarity is, again, that's in our data sheet, 0.04, 0.04. Okay. And that's, again, that's the same every time. So what you can do is you can click there. See that little box there at the bottom? You just drag it down and it'll fill in the cells like that. And then again, molarity, so equal sign tells you you're doing a function. You pick the cell you want to multiply by. So times, now we have a problem here. See, I have that in milliliters. I'm going to drag that down. We don't want it in milliliters. We want it in liters. We have to divide that by 1,000. So 0.025. I'm going to drag that down. So that's the same. So now we have the correct number of moles here. Okay. And then let's do the same thing here. But now we're going to do the H2O2. This is going to be H2O2. Now, generally, what you can do is you can copy and paste a table that you produce in a spreadsheet program like this one right here into your Word document or into your Google Drive word processing one. Okay, word processing program. So I'm looking at chart 1, and the volumes for H2O2, they vary. They're at 25. So here's what I'm going to do. Equal sign 25 over 1,000, right? So that did the calculation for me. And then it's the same for the first 3 experiments. And then it goes to 0.0, then it goes to 50. So equal sign 50 over 1,000. All right, everyone understand why I'm doing that? I'm doing that because we have to convert it into liters. The measurements are in milliliters. And then the last one is 100 milliliters. So equal sign 100 divided by 1,000. Okay. The concentration of the H2O2 is 0.2. I'm just going to fill that down. And now we can do our concentration times our volume and then autofill that. And now we have completed table 1. Our goal in this table was to get the initial moles. So really it should say initial moles, but that's okay. So what I'm going to do is I'm going to bold these just so that we recognize these are the numbers we're going to use for the next table. Okay. So table 2, let's come up here. Is initial molarity. Okay, so let me put this up on. Okay, so there's table 2, initial molarity. Okay, the total volume in milliliters and then the total volume in liters. Okay, that's what that has right there. So now the total volume in milliliters is the volume of everything added together. So I want to take you through so that you can see that. Okay. Here we go. Okay, so let's go through it. The total volume is everything you're adding together in the same solution. So here's experiment 1. The amount of water was 425, the amount of HCl was 10, the amount of Ki was 10, the amount of starch was 5, the amount of Na2S2O3 was 25, the amount of H2O2 is also 25. Now you just add those up, and what do you get? Okay, take a moment and add that up. 425 plus 10, plus another 10, plus another 5. Well, wait, what's 10 plus 10 plus 5? It's 25, right? So you really have 425 plus 25, plus another 25, plus another 25, okay? Actually, it says here, right? Total volume 500 milliliters. Okay. Again, we're not using this chart down here. You can ignore this data set over here. Okay. So now coming back to our calculations here, we have a total volume. So this, let me bring this up. So we have a total volume equals 500 ml. And let's put that into liters. So how do we convert milliliters to liters? You divide by 1,000. So 500 divided by 1,000. Now, why didn't I just click on that cell? The reason I didn't click on that cell, so this is our volume in liters. The reason I didn't just click on this cell to do that calculation is I put text in there. I put words in there, and that's going to mess it up. It can only handle numbers. So even if you put the units in there, it'll mess the software up. I'll show you. Equal sign this over 1,000. See, doesn't understand it. So, you know, another way to do this is you write, okay, 500 here, and then equal sign that divided by 1,000. Okay. Now that works. All right. So that's our total volume. Okay. So table 2 then, what it has and I'm going back to the procedure. Is it has the initial moles, right, of Ki, initial moles of Na2S2O3, initial moles of H2O2. Okay, those are the values that we calculated in the previous table, table 1. So all you got to do is copy and paste those values that you just calculated into this one right here. And then in the next column for each one, it says bracket Ki bracket. That means concentration of Ki, right? Remember the bracket notation means concentration. So concentration of Ki, the 0 means initial. So you find the initial molarity by taking the initial moles of the substance and dividing that by the volume in liters. So what would we divide it by? We would take this number here and we would divide it by our volume, which is 0.5 liters. So really what that's going to do, you're dividing by 0.5, it's going to double that number there. So whatever you have for initial moles here, it's going to double it because you're dividing by 0.5. Same thing for the Na2S2O3, same thing for the H2O2, right? You're going to take the initial moles from table 1, divide by 0.5, and that's going to give you your initial concentration. Now, the reason we need that is that when we do kinetics calculations, we do what's called the method of initial rates. And the method of initial rates is you put in initial concentrations that are known, and then you watch what happens to the reaction. You measure how fast the reaction proceeds. So what's happening then in this table is we're figuring out what the initial concentrations are. So let me show you here. Okay. So let's do, initial moles of Ki, right? And then concentration Ki 0. Let's go ahead and make it look a little prettier. There we go. Okay. So coming back to table 1, what did we have? We had, here's our initial moles right there. So I'm going to put those here. Oops, sorry. Didn't really like to do that, did it? All right. I'm going to copy. I'm going to come into table 2. And I'm going to go to paste special, just values, paste special values. See, sometimes it gets confused about where the cells are coming from. So if you just hit paste, it will lose the information. But if you go up to paste, so it's edit, paste special, and just do values, you're set. It'll work. Okay. And then again, this divided by 0.5. Well, we could, let's be. Actually, let me show you, be careful about this. If you are going to use this, which you will for all 5 of these, you have to be a little bit careful. What you do is you put designators that we're not going to shift down after the 0.5. We're going to use the 0.5 each time. So you put $, the letter, and then $, the number. Okay. Now you can autofill. If you just put C2, which is right here, C2, and then you autofill, it's going to do the next one, C3, and there's nothing there, so we'll get confused. So you put $, C, that's telling you just use the value that's in that cell for all of the ones that we're doing here, okay? Now look what happened to the concentration. This is going to be key for later on. The initial concentration of Ki changed from experiment 1 to experiment 2 to experiment 3. It's changing. So in experiments 1, 2, and 3, what we're doing is we're trying to find out how the reaction rate changes when Ki is changing. But in experiment 4 and 5, it doesn't change from 3. 3, 4, and 5 are the same. So there's no change in Ki. So any change in the reaction rate can't be because of Ki for experiment 3, 4, and 5. It has to be from something else. Whereas any change from experiment 1, 2, and 3, comparing those 3 values, Ki could be a factor in affecting how fast the reaction is. Okay. Now, let's come back to table one. Table one, we then had Na2SO3, so I'm going to copy those values here. Now there, I just hit paste and it worked. This is Na2S2O3. Initial, right? Those are the initial concentrations. That's what we're doing, the method of initial rates. Actually, let me grab all these cells and highlight. There we go. Excellent. Okay. So then concentration of Na2S2O3, 0, right? How do we do that? Again, the concentration is 0.5. So you just take the initial moles, okay, divide that by $C, $2, then you can autofill. Okay, now I got this wrong. This is not concentrations, it's initial moles. There we go. Okay, sorry about that. So this is the initial concentration. Now look what happens here. Okay, I guess we don't need these to be bold. Change. Oh, wait a minute. Okay, hold on a second. Let me come back here. I'm thinking there's something wrong. See, yep. So be careful when you paste. The initial moles is the same, 0.001. I didn't pick that up. So what I'm going to do is I'm going to redo that. You have to be very careful with these. So I'm going to highlight these. I'm going to copy. That's another thing it'll do. It'll actually just like change the values. So now we're going to go paste special and then values only. There we go. Now we got the right values. So look at Na2S2O3. It doesn't change at all. So it's not going to change. Any changes in the reaction rate are not going to be an effect of Na2S2O3. Okay, it's part of the chemistry. But we do have H2O2. So again, initial moles of H2O2. And then you got initial concentration of H2O2. Okay. So let's come back over to table one. We have our initial moles. There it is. Copy. So Command C. I'm sorry, using an apple. So it's Command C. And then again, let's not fall into that trap. Let's do paste special, values only. Okay. And then equal sign, initial moles over, $C, $2, and autofill. And there we go. Now we've completed table 2. Okay. Those are the values that we're looking for. Now, let's remind ourselves that this particular reaction, the rate of the reaction is K times the concentration of I minus or Ki if you want. Let's do the H2O2 first. H2O2 times the concentration of Ki. But I'm missing something here. We want to know what these exponents are, right? The orders of the reactants. So I'm going to put an X there. So raised to the X. I can't do superscript in this format. So I'll just use that little caret symbol. The little caret is this one right here. That means raised to the power of. So raised to the power of X times Ki raised to the power of Y. That's what we're trying to figure out. So in part 1, we're trying to find the value of K, X, and Y. That's what we're trying to do. So by knowing the initial concentrations of H2O2 and Ki, we're going to be able to figure out what X and Y are. And notice the way it's set up. When Ki is changing concentration, experiment 1, 2, 3, H2O2 is not changing. We're keeping one variable constant and we're changing the other. Then for the last 3 experiments, H2O2 is changing, but Ki is not changing. That's the key here. We change one, but not the other. If we change both of them, well, you can change both of them, but you have to be kind of clever about it. So if you think about it, from experiment 1, which is right here, to experiment 5, which is right there, we're changing both of them, right? This one went up 0.02 to 0.06, that's a factor of 3. This went from 0.01 to 0.04, that's a factor of 4. So they are both changing from there to there, okay? But experiment 1, 2, 3, the pattern is change this one, and then 3, 4, 5, change this one, okay? And there's your table 2. Now, I want to show you table 3. Table 3 is where, and I'm sorry, but when you look at this, table 3, the wording, the identifier of the table is on a different page than the actual table. It's a formatting issue. So table 3 is right at the discussion of it is right after table 2. And then there's some discussion of it, of how to get the calculation. And then that's right here. Okay, so here's the main point of this. Is sort of a little step you have to do. We're now going to find the moles of hydrogen peroxide used, H2O2, okay? To do that calculation, what we do is we use the stoichiometry of the reaction, okay? And the stoichiometry works out that for every mole of H2O2 that reacts, 2 moles of S2O3 react of thiosulfate, okay? 1-to-2 ratio. So what it says here is to find the moles of H2O2, you take the initial moles of S2O3, thiosulfate, and just multiply by half, 1-to-2 ratio, and that will give you the moles of H2O2, okay? Now keep in mind that the number of moles of thiosulfate that are the initial moles of thiosulfate. Okay, so I'm going to put that there. Initial moles of thiosulfate, it's the same every time, right? We kept that constant, 0.001. So that means the moles of H2O2 that react or are used is going to be the same every time, because it's just the initial moles of S2O3 times 1/2. Now, why does it not say S2O3? Why does it say Na2S2O3? That's something from Chem 11. When you dissolve a salt into water, it breaks up into ions. So every time one of the sodium thiosulfates breaks up, it gives you 1 thiosulfate. So it's the same number, okay? So now, when we come back over to table 3, let me actually show you. I'm not going to do the calculation here. I'm just going to actually discuss it with you. With this one right here, the initial moles of H2O2 is just going to be 1/2 times the initial moles of thiosulfate from table 2. So that's going to give you those numbers. Again, we did the volume in the previous one. That's 0.5 liters. So that's going to be 0.5. Now here, it's the concentration of H2O2 used. How do you calculate concentration? Concentration in the units of moles per liter, or molarity, is just the moles used divided by the volume in liters. So you're just going to take your moles that were used here and divide that by the number of liters, and that will give you the concentration of H2O2 used. Now, what about the time? So the time, that data, again, you're going to have to kind of be organized here. That data is coming from, sorry, hold on 1 second. It's coming from the data sheet that I gave you, right? So here's this sheet right here, and here's your data for time. 4:35 seconds, 2:15, 1:43, 69, and then 34. So there's your 5 experiments. There's your 5 times. So those numbers you can pay or type in back into table 3. Okay. So here's your table 3. Times you're going to put in there. And then rate is easy. Rate is just change in concentration over change in time. Now, actually, the amount being used is positive, but the way we're defining the rate is negative change in concentration. The change in concentration is actually negative. So if this is negative and then you multiply by negative, you get a positive. Or you can just use the positive value here. Either one will work. Divide that by the times, and that will give you the rates. Now, that's actually technically called the initial rate, okay? Because those were initial. Actually, that's not true. I take that back. That's just the rate. It's the average rate because we did it over a long period of time, and it's because the amount of H2O2 that was used during the whole process. So it's not the initial rate, it's just the rate, okay? The rate is in molarity, not moles, but molarity per second, because you're using molarity divided by time. Now, table 4. Table 4, what you're going to do is you're just going to take the logs of the rates that you calculated right here, and then you're going to take the initial concentrations again. You're just going to copy and paste those over from your previous table, from table 2. Okay, take the log of that concentration. Then you're going to take the initial concentration of Ki. I know it says I minus, but it's the same as Ki. And then you're going to take the log. Now, the log that you're doing is base 10. So let me see if I can pull this off. I may not be able to do it. Let me just come over here. I'll bring this up over here. Okay. And there we go. Okay. So this is the scientific calculator right here on my Mac. Okay. So if we come back to the actual concentrations that we got, the initial concentrations, I have to find it. I have so many documents over here on this. I'm sorry, but we do have a lot. Okay. So let's take, for example, the Ki. The initial concentration was 0.02, 0.04, 0.06, 0.06, and 0.06. Okay. So how do we do that? Well, let's say we want to do the log of Ki, and the concentration is 0.02. Okay, there's your initial concentration. All you got to do is put that number in and then hit log base 10. Don't do ln, do log base 10. And you get negative 1.699. Okay, you're going to get negatives here. And the reason you're going to get negatives here is that every number we're putting in is less than 1, 0.1, 0.2, 0.3, 0.4. When a number is less than 1, the log of it will be negative. Let's try another one. Let's try a concentration of 0.02. So here's our initial concentration, 0.02. Hit the log of it. I'm sorry. Let's do 0.01 log, negative 2. 0.02 log, negative 1.699. 0.03 log, negative 1.52. So you're going to get negative numbers for all of these, okay? And the negatives are going to be in your numbers. You definitely want to have those written in your table, okay? Again, you're typing up this table yourself. Oh, I should show you. You can also do this in your calculator. I mean, in the spreadsheet. You don't have to use the calculator. I just wanted to show you how to do it on that one. But let me come back over here. And I'm sorry. There we go. And I'm going to come back to table 2. So let's say we're doing the Ki. So here's your initial concentration of Ki. Let me copy it and then come over to table 3. Oops. See, I did it again. So you got to do paste special values only. There we go. Okay. So now log Ki. I know it says I minus, but that's fine. Same thing. Okay. Same thing. Let's put this in the middle. Okay. So here's how you do it on the computer. Equals sign. This is using Google Docs. LOG. Parentheses. Click on the cell you want to do, and then close the parentheses. It's actually going to give you a little highlight of what the value you expect it to be, negative 1.699, right? Suggested fill, yeah, that's fine. Okay, so you're going to have, now notice, it's changing from 1, 2, 3, experiments 1, 2, 3, not changing from 3, 4, 5, but that makes sense, right? Because if the concentrations aren't changing, the log of it's not going to change, okay? You're going to do the same thing for H2O2. So let me copy that. Again, paste values, and then log concentration of H2O2. Equal sign LOG, parentheses, the number you want to do. The number is less than 1, so you should get a negative, and yes, you do. Okay. And then you've also got the rate. So let me just insert here. Okay, you're going to have the rate, and then you're going to have the log of the rate. Okay, so remember, you're going to do that calculation of the initial rate. That's actually table 3. So really, this is table 4. I'm sorry. So really, these are in table 4. I got the two tables confused. In table 3, you're going to figure out the rate. And then you just, let's say the rate here is 0.04. Then you're going to just do the log of that rate. So equal sign LOG. That one. I didn't go through all the calculations in the table 3. Let me do this table. And then make this table 4. There we go. Okay. So I skipped over 3 because I just kind of discussed how to do it, but this is table 4. Okay, now you got your table 4. Logarithms, right? So log of the rate, and then log of H2O2, log of Ki. Now it's the point where you're going to be doing graphing, okay? And what I'm going to do is I'm going to split that up into a second video of how to do the graphing aspect of this. So for right now, what you want to do is you want to go through it yourself and do all these calculations of tables 1 through 4 with your data set. And then I will do a separate video regarding the graphical analysis, okay?